The universe is vast and teeming with wonders, but it is also an endless stage of isolation. Scattered across the immense cosmic canvas are objects so detached from everything else that their very existence challenges our understanding of connection, companionship, and survival. These are the loneliest entities in the cosmos: rogue planets, runaway stars, intergalactic stars, dark matter, and black holes, all adrift in near-infinite voids of space. Each of these wanderers tells a unique story, both haunting and profound, of how isolation shapes the nature of existence. 1. Rogue planets, the orphaned drifters. Rogue planets, also called orphan planets, are celestial bodies that once belonged to solar systems. In the violent early days of planetary formation, massive gravitational interactions between nascent planets and their stars often lead to chaos. A larger planet might sling a smaller one out of orbit, ejecting it into interstellar space. These planetary refugees now drift aimlessly, untethered to any star. Stars play a crucial role in a planet's existence, providing light, heat, and energy. Without a star, rogue planets are cold, desolate worlds. Surface temperatures often plummet to just a few degrees above absolute zero. However, some rogue planets may have internal heat sources, such as radioactive decay in their cores or friction caused by tidal forces. For example, Earth generates significant geothermal heat, which theoretically could sustain subsurface oceans or pockets of warmth on a rogue planet. Astronomers have identified several rogue planet candidates, such as those detected by gravitational microlensing, a phenomenon where a planet's gravity briefly bends the light of a background star. An example is the potential rogue planet CFB-DSIR 2149-0403, which lies about 100 light-years away. This planet-sized object lacks a host star and is a prime candidate for studying the nature of these wanderers. A rogue planet with a thick atmosphere rich in hydrogen could theoretically trap heat, allowing subsurface oceans to remain liquid. Life could thrive in these hidden environments, much like microorganisms found deep beneath Earth's crust or in Antarctic subglacial lakes. 2. Runaway stars, the galactic fugitives. Runaway stars are stellar outcasts flung from their home systems at incredible speeds. These stars gain their velocity through one of two mechanisms. 1. Binary star interactions. If one star in a binary pair goes supernova, the surviving star might be ejected at tremendous speeds. 2. Gravitational encounters. In dense star clusters, close encounters between stars can result in one being hurled away while the others remain gravitationally bound. Some runaway stars, known as hypervelocity stars, travel so fast, up to 1,500 km per second, that they can escape their home galaxy entirely. One notable example is the star HEO 4375439, which is speeding away from the Milky Way at nearly 2.6 million km per hour. It likely originated in the Large Magellanic Cloud, a nearby dwarf galaxy, and was ejected during a gravitational interaction. Imagine a blazing sun hurtling through the void, leaving behind its stellar companions and illuminating only the empty dark. Runaway stars often end up in the galactic halo, a sparsely populated region surrounding the central plane of a galaxy. Here, these stars shine in solitude, separated from the bustling neighborhoods of the galactic core. 3. Intergalactic stars, castaways between galaxies. During galactic collisions or mergers, gravitational forces can slingshot stars out of their galaxies. These intergalactic stars now drift in the vast emptiness between galaxies, known as the intergalactic medium. The distances involved are staggering. An intergalactic star might be millions of light-years from the nearest galaxy. In the Virgo cluster, a massive collection of galaxies located about 65 million light-years away, astronomers have identified hundreds of billions of stars floating freely between galaxies. These stars were likely stripped from their home galaxies during tidal interactions. For intergalactic stars, isolation is nearly incomprehensible. The light from neighboring galaxies might appear as faint smudges in the distance, and the stars themselves would have no planets, companions, or close neighbors. 4. Rogue black holes, invisible drifters. Black holes typically reside at the centers of galaxies or form from the collapse of massive stars. However, when galaxies collide or a black hole experiences a gravitational slingshot effect, it can be ejected from its host galaxy. These rogue black holes, some containing millions of solar masses, become cosmic nomads. Black holes don't emit light, making them difficult to detect in isolation. However, their immense gravity warps spacetime, bending the light from background stars. Astronomers can spot rogue black holes by observing these gravitational lensing effects or by detecting X-rays emitted as they consume stray matter. In 2022, astronomers discovered a black hole candidate wandering 5,000 light-years from Earth. Using the Hubble Space Telescope, they observed how the object's gravity distorted the light of a background star, providing direct evidence of a rogue black hole. 5. The cosmic voids, the universe's deserts. Cosmic voids are vast regions of space that contain very little matter, no stars, few galaxies, and sparse gas. They can span hundreds of millions of light-years and are surrounded by filaments of galaxies that make up the cosmic web. Any object within a void is incredibly isolated. For instance, the Boots void, one of the largest known voids, is about 330 million light-years across. If Earth were located in the Boots void, the night sky would appear nearly empty, devoid of the dense clusters of stars and galaxies we see today. What do these loners teach us? Survival in isolation. The existence of these isolated objects demonstrates the resilience of matter in the universe. Rogue planets and stars challenge our assumptions about habitability and stability, suggesting that life and energy could emerge even in the harshest conditions. The nature of cosmic interactions. Many of these loners were created through violent events, collisions, supernovae, and gravitational interactions. Their stories are reminders of the dynamic and often chaotic nature of the cosmos. Philosophical implications. These wanderers force us to confront the vastness of the universe and our own place within it. Just as a rogue planet might drift in solitude, humanity exists on a pale blue dot in the cosmic void. Yet, even in isolation, there is beauty, persistence, and the potential for discovery. The loneliest objects in the universe are not merely curiosities, they are profound reminders of the cosmos's extremes. From rogue planets to void dwellers, they show us that even in the darkest, most isolated corners of existence, there is still movement, energy, and the potential for life. As we continue to explore the universe, these wanderers offer a haunting yet inspiring glimpse into the resilience of the cosmos.